Okay, number 2, we have these same instructions. So we have f of x equals x to the 4th minus 3x squared minus 4. So if we start with the possible real zeros and turning points, possible real zeros, that is the highest degree. It's degree 4. And turning points, that is degree minus 1. So 3. So possibly we have 4 real zeros. It doesn't mean we have 4 real zeros, but we might. We can't have more than that. And we might have up to 3 turning points. Okay, so then next we need to factor and solve. So to solve this, we take the polynomial x to the 4th minus 3x squared minus 4, set it equal to 0, and solve it. So first we look for a GCF. There is not a greatest common factor here. None of them have anything in common. So we're just going to factor it. So some people might worry that we have an x to the 4th power. It's not x squared. But when it's x squared, like the last example we just did, and the middle term is x to the 1st power, what I did was I set up 2 sets of parentheses, one for each factor. And then I took x, my lead x, normally x squared, and I split up x times x gives me x squared. Well, since this is an even number, I could split this up also. So I could split this up as x squared times x squared, and that gives me x to the 4th. And as long as the middle degree is half of the first degree, you can do that. Now if this was like x to the 5th, then we would have a problem. But it's x to the 4th, and then the middle one is half of it. So it could be like x to the 12th, and then x to the 6th. And we could do the same process. So we're just going to treat it the same as we would a quadratic. It's just, now we have x squareds instead of x to the 1st for our factors. All right, so then I'm going to look at my second sign. It's negative. Since it's negative, it tells me I'm going to have one positive and one negative factor. When the second symbol was positive, it told me they were the same, and I had to look to the first one to see what they would be. This one, it's negative, so it says they're opposite. So I have one of each. Now I want to multiply to negative 4, and I want to add to negative 3. Factors of 4 are 2 times 2 and 4 times 1. Well, 2 times 2 is not going to get me to a 3. So I have to do 4 times 1. If I want to add to get to a negative 3, I need the larger number to be negative. So I'm going to use negative 4 and positive 1. I could do a quick check on this. X squared times x squared does give me x to the 4th. And positive 1 and negative 4 gives me negative 4 if I multiply. And if I add to the middle, I have negative 4 plus 1 is negative 3. That works. So I have factored. Now I need to solve. To solve, I set each factor equal to 0. So I have x squared plus 1 equals 0. And I have x squared minus 4 equals 0. To solve, I subtract 1. So I have x squared equals negative 1. X squared, so I take a square root. So x equals plus or minus the square root of negative 1. Square root of negative 1 is the imaginary unit because you cannot take a square root of a negative, right? You cannot take an even root of a negative. So x equals plus or minus I. That is 2 solutions, positive I, negative I. They're both imaginary. All right, so then the other factor, x squared minus 4 equals 0. So x squared equals 4. So then x equals plus or minus the square root of 4. Square root of 4 is 2. So x equals plus or minus 2. So that's 2 more solutions. So in total, I have 4 solutions. But my real solutions, I only have 2 of them. So this is just a little side note on the side. I'm going to say all zeros. I have a positive I have a negative I have a positive 2, and a negative 2. But if I look at just the real zeros, then I leave out the imaginary ones. So if I was just graphing, I wouldn't graph the imaginary ones. I would just be graphing positive 2 and negative 2 as my zeros. So that's just, like I said, a little side note. The difference between all zeros and real zeros. If it's just asking for real zeros, you leave off the imaginary ones, because you can't graph those. And the last example, we have h of x equals negative x to the 4th minus x to the 3rd plus 2x squared. Work it the same as we did the others. Possible real zeros equal to the highest degree. Highest degree is degree 4. So 4 possible real zeros. Turning points is the degree minus 1. So 4 minus 1 gives me 3. That's part of my answer. All right, so I did the possible real zeros, I did the turning points, then I need to solve it. So I have negative x to the 4th power minus x to the 3rd power plus 2x squared. Set it equal to 0 so I can solve. First, you always look for a greatest common factor. I have a greatest common factor because they all have x's. They all have 2. So x squared is my greatest common factor. But whenever I do factoring, I like for my a value to be positive, and this one's negative. So I'm going to make my greatest common factor a negative x squared. Because then my factoring will be easier. If I just bring the negative out, my a value is no longer negative. It just makes things a lot simpler to make the GCF negative instead. So now I have x squared plus x minus 2 left in parentheses. All right, so I'm going to factor that. Again, it's pretty simple factoring because the a value is positive 1. I have negative x squared on the outside. I'm going to set up 2 sets of parentheses for my factors. My lead degree is 2, so I have x squared, so I'm going to split up my x squared into x and x, because x times x gives me x squared. To figure out my symbols, plus or minus, I look at the second symbol. It's negative, so that tells me they're opposite. I have one of each. So I'm just going to fill them in. It doesn't matter which one you make positive and negative, as long as you put the correct number with it. If I'm multiplying to 2 and I'm adding to positive 1, multiplying to 2, there's only one way to multiply to 2, 2 times 1. If I want to add to a positive 1, I want my larger number to be positive. So the 2 has to be positive. So the 1 is negative. So to check it, positive 2 times negative 1 gives me negative 2. Positive 2 minus 1 gives me positive 1. So it checks. So I factored it. After I factor, I set my factors equal to 0. So negative x squared equals 0. That just gives me x equals 0. Right? Because you divide by a negative. 0 divided by negative 1 is still 0. Square root of 0 is still 0. So x equals 0. Then I take x plus 2 equal to 0, so x equals negative 2. I take x minus 1 equal to 0, so x equals positive 1. And these are my 3 solutions. my 3 zeros. But there's also something special about this first one at 0. Because that is x squared equals 0. So if we were to take this and split it up into its factors, the negative, I can just say that's negative 1. And then I have x squared, so that's like x times x. So negative 1 times x, that's negative x squared. And then, so the negative 1 doesn't really tell me anything, right? If I set these factors equal to 0, but then I say x equals 0 and x equals 0. So I end up with 2 solutions. They're both 0, but there's 2 of them. So that tells me that this 0 has a multiplicity of 2. There's a multiplicity of 2 because this 0 was a degree 2. Okay. These were degree 1. They were x to the first power, and I solved them. So they have a multiplicity of 1. So really I have 2 here, 3, 4. I have 4 real zeros, just 2 of them are in the same location.
Does that change the graph at all?
It does. Multiplicity is the number of times a value is listed as a 0. Is the number of times a value is listed as a 0. And I'm going to go more into how it affects the graph on Monday, but for real quick, if I were to graph this, if I wanted to sketch this graph, I have 0, 0. I have negative 2, so come over here to negative 2. And I have 1. So that's where my x-intercepts are. This is negative and even. So both ends are pointing down. The end behavior is pointing to negative infinity on both sides. So from the outside intercepts, it goes down. And when you have an odd multiplicity, your graph is going to pass through the 0 at the x-axis. So if this is negative 2, that's a multiplicity of 1. That's an odd multiplicity. So this graph is going to pass through that 0. And then my next 0 is at 0, and it has a multiplicity of 2. So when you have an even multiplicity, you're going to bounce off. You're going to hit the 0 and bounce off again. And then my last one was at 1. And it's x to the first power, so it passes through again. An even multiplicity will bounce off. So I could tell my graph looks something like that. That's just, again, I don't know exactly what those other values were. It's a quick sketch of the graph. And we're going to talk more about multiplicity on Monday. But right now it's just asking you for possible real zeros, turning points, and the solutions, or the zeros. So your homework assignment is page 104, numbers 23 to 31, odds only, and 35, 37. And if you would like a challenge question, number 93 is honors. It's an honors level question. You're welcome to try it if you want. It is not required.